In the next question, the only information given in the question itself, in this statement itself, is a x square plus 2bxy plus cy square is greater than 0 for all pairs of real xy minus obviously 0 comma 0. Let's see what all information we can extract from this. So if x is equals to 0 or y equals to 0 using this condition, obviously if x is 0, y has to be non-zero. So we get cy square greater than 0, which means c is greater than 0. From this, similarly, we get a greater than 0. Now when both x and y are non-zero, we can divide by y square. As it is positive, the inequality stands. So we get a x upon y square plus 2b x upon y plus c greater than 0 for all pairs of xy. So setting y equals to 1, we essentially get ax square plus 2bx plus c is greater than 0 for all x, which gives us that the discriminant of this quadratic should be less than 0, which means b square minus 4ac. So b here is 2b, so minus 4ac is less than 0. b square minus ac less than 0. Now let's look at the options. So a option, b square is 49 by 4. So this basically this condition means for triplet ABC to be in S, this condition should hold. So a option is check this triplet if whether this triplet is in S. So b square is 49 by 4 minus AC is 12. So this is equals to 1 by 4, which is greater than 0. So a option is incorrect. Checking for b option, b square minus 3 into 12 is 1 by 4 is less than 0, which implies mod b is less than half, which implies that mod of 2b is less than 1. So b option is correct. For c option, for a system of linear equations to have a unique solution, remember c and a are both greater than 0. We can write a by b should not be equals to b by c. In that case, this has a unique solution, which means ac should not be equals to b square, which indeed is the case because b square is less than ac, strictly less than ac. So c option is correct. Now so far the question has been straightforward, and again this question is not really from any particular section, though it uses some quadratic equation, basics of some quadratic equations. To check for the d option, again a plus 1 by b should not be equals to b upon c plus 1. So implies a plus 1 into c plus 1 should not be b square. So although this is not immediately clear, but when we expand it, remember this means that b square is less than ac, and a and c are both greater than 0. So this whole thing is positive. So b square is already less than ac, and what we are doing is we are adding some positive terms, which means that b square clearly cannot be equals to a plus 1 into let's write it, b square is clearly less than ac plus a plus c plus 1. So this inequality is true. So d option is also correct.